Okay, we can pretty quickly see that this question is all about parametric equations. It says so directly right there. We're given the parametric equations x equals and y equals, and we're asked to get a Cartesian equation. So there's no calculus here, no integration or differentiation. We just need to do the work to change parametric equations into Cartesian. What does that mean? That means taking the xy equations and trying to eliminate t. And when trigonometry is involved, we try and use identities to do that nice and neatly. So if we look at the x and y equations, there's not much we can do with y directly, but x, there's plenty of potential there. So let's copy out x. X is 4 cos of t plus pi over 6. Cos of t plus pi over 6, that's the cos a plus b formulae from the formula book. So we've got a factor of 4. We get cos t cos pi over 6. And then there's a negative sign, negative, and we get sine t sine pi over 6. Now, pi over 6 is just an angle, it's the same as 30 degrees, so cosine pi over 6 and sine pi over 6 have values. So let's think about that. Cosine pi over 6 is root 3 over 2, multiplied by the 4 makes 2 root 3 cos t. And sine pi over 6 is a half, multiplied by the 4 at the front is 2, so minus 2 sine t. So we've simplified a bit the x function, and we still have the y function, which is 2 sine t. So we need to work with these, get x and y connected, but without involving t at all. Now notice at the end of the x function, we've got 2 sine t here, which is just y. So x is 2 root 3 cos t minus y. We can do that substitution directly, and it's only the cos t now which causes the headache, causes the problems. There's a few different ways you can do the algebra from here on, but we're going to take a bit of inspiration from the form of the answer. It involves squared, and in particular it involves x plus y squared at the start there. So I'm going to use that inspiration to move this minus y term over to create x plus y equals 2 root 3 cos t. And it's squared in the answer. I'm going to square it now. So squaring both sides, x plus y squared equals 2 root 3 squared. 2 root 3 multiplied by 2 root 3 is 12. Cos t, when it's squared, we write as cos squared t. Now t is still here. We're trying to get rid of it. We've got cosine t, but y is in terms of sine t. So we're going to use an identity now, which is to replace the cos squared. So we write again x plus y squared equals 12. Instead of cos squared, we're going to have 1 minus sine squared t. Okay, now we can relate that back to y. So x plus y squared is 12, 1 minus sine t squared, and sine t is y divided by 2. If you go back to the equation that we had up here, sine t is y over 2, so sine squared t is y over 2 all squared in these brackets. Now we just need to simplify. T has gone, so we're in a good position. Let's just simplify that. 12 multiplied by 1 is 12, minus y over 2 when you square it is y squared over 4, and multiplied by 12, that leaves us with 3y squared. And the question wanted it in this form, x plus y squared plus 3y squared, make it positive on the left side, equals 12. Let's just look back. The green box says, written in the form x plus y squared plus ay squared equals b, where a and b are integers to be found. Let's double check that. Yeah, we've got a equals 3, that's this one, and we've got b equals 12, that's that one, and we've made it.